Hey everyone, can everyone hear me? Cool. All right, let me go ahead and share my screen. Can everyone see my screen? All right, great. So today we're going to talk about how to handle authorization in a microservices environment. My name's Shawn McCarthy. I am a customer engineer at OSO, and I'll be walking us through the presentation and the demonstration today. If you have any questions, please feel free to unmute, or if you'd like, you can ask questions within the chat. And Hazal, my coworker, will help make sure that we get your questions answered. With that said, let's go ahead and begin. So, quick agenda. We're going to talk a little bit about microservices. I'm going to walk through the demonstration code that I put together. We're going to give some definitions to kind of common patterns that we see within authorization. We're going to talk about OSO's authorization platform, and then we'll follow up with a demo and any other Q&A. So this is a very simple microservice application that I put together. But typically when we talk about microservices, especially within OSO, we think about discrete services. So for example, here I have organizations that manage both users and organizations, and that service has its own database. And then we also have a documents service, which has its own database as well that manages documents and how they're related to the users that created those documents, as well as the organizations for which those users are part of. So you can already kind of see we have a dotted line between the organizations and the documents, and this is where microservices typically become pretty tricky. As we start to create our discrete services, those services typically require us to share pieces of information with the other services. So what are the most efficient ways to do that? And how do we begin to now introduce authorization into these services are the common questions that we need to answer as we design our system. So here within our design for our simple microservice here, we are duplicating some data for our organizations to be able to ensure that we know that documents are associated with users and organizations that created that. And I'll show a little bit of what that looks like in a demonstration. But these are the things that become very hard these become challenging questions that we typically have to ask. So if we think about how we end up looking at authorization, one of the things that we typically ask is do we begin to centralize our authorization, meaning that we replicate our data into our central authorization service, or can we allow the authorization service to use its logic to execute local queries that can be pushed down to the database? And in OSO, we support this concept called local authorization, which we'll be talking about today. So before we jump into the demonstration, into the topics of local authorization and demonstrating how that works, I want to just talk about a couple of different access control models or control patterns that we typically cover within OSO. So the first thing you might hear me say is RBAC, or role-based access control. An example of this is the admin group can change files and permissions on a service. The next one you might hear is ReBAC, or relationship-based access control. The file owner can assign other admins to a system. This is really all about building relationships between various resources that we're looking to protect. And then finally, we'll talk about like ABAC, or attribute-based access control. So for example, all users can read a file if the file is marked as public, right? So this is assigning an attribute to a resource which can grant different permissions based off of the type of attribute that's assigned and how we evaluate that. Does that make sense? Any questions, comments? Okay. So these common patterns are supported by OSO in our platform, and OSO is an authorization as a service. It was one of the earlier as a authorization as a platform serve authorization as a service platforms that were built. So essentially, what we have is your application that you're building will make authorization requests that are evaluated by OSO's cloud-based platform. And essentially we can do this evaluation to answer questions such as allow or deny access to a resource. We can also answer complex questions such as what files does Alice have read access to, and this can return a list of files. Or you can ask it in other ways, such as what permissions does Alice have on file X? And we also have a very rich query interface that allows you to create more complex queries about your policy to build things like sharing widgets and stuff like that you might want to determine how, not that a user has access, but how they gain that access. So if you think of things like the Notion sharing widget, you not only see the user, you also not only see the users that have access to the file, but you also see how they got that access as well. So so in OSO, there's a couple of different ways that we talk about how we determine if a user is allowed or denied resources. And here in this slide, rather, where we see the idea of policy and facts. So think of policy as the logic that defines the rules that are used to help determine if what type of access the user has. Facts are really data. And here today, we're going to be talking about using facts, but also using our database to represent those facts rather than storing them centrally in OSO. Any questions, comments? You're more than welcome to either drop it in the chat or go ahead and ask. All right. So let's go ahead and talk about, so we talked a little bit about some of these, but the idea of really one of the core concepts of OSO with the authorization as a service is we're really focusing on centralizing our logic. We can also store facts within OSO, but we can decouple the data to ensure that we're getting the best performance that we want from our authorization platform. And one of the things that is extremely important here is that we're going to start to build a testable policy that we can ensure to ensure that our authorization policy is meeting all of our requirements. So what we're going to really focus on today is the idea of local authorization, where we're going to keep the data in our app. And also when we evaluate the policy, or when we evaluate the request, we're going to do partial evaluation of the policy, as well as return how we get the answer from our database. And I'll show a little bit of what that looks like in a moment. This here is just a quick view of kind of what we're going to be seeing within our demonstration today when we talk about local authorization. So our application will ask OSO, can Alice add a user to the organization? OSO, rather than returning yes or no, is actually going to return, is Alice an organization admin? And I'll show how we define the bindings so that OSO can correctly ask that question back to the application. Our application will then turn around and take that question and send that to our local database, and then the database will return the answer yes. And if it's yes, then we go and add the user to the application. This is an extremely powerful feature of OSO because it allows for two things. One, it allows us to start getting up and running very quickly using OSO as a authorization service. But two, if we start to think about it, those data replication issues that we typically are worried about within our microservices environment, how we do synchronization, reconciliation, we can start to plan for those in a way of, hey, for right now, we don't move our data. And then we think about when it's the best time to move data, start synchronizing data, right? So we start doing a cost benefit analysis. Does it make more sense to keep the data local, or am I going to get better performance if I introduce a synchronization pattern into our microservices architecture? And if the costs outweigh if the benefits outweigh the costs, then we start to look at how we implement that pattern. One of the other things that local authorization also gives us is the idea of local list filtering. So typically, when we have, for example, let's say a user has a large number of files, maybe in the thousands, hundreds of thousands of files that are stored locally. If we had to put all of that data into OSO, then we wouldn't necessarily be able to do efficient list filtering, especially if we wanted to sort, paginate the data. We can now store only the data that's needed to partially answer the question, and then let OSO, and then let the database answer the rest of that question using list filtering that is pushed down into the database so that the database can do all of the work that it's optimized to do, whether it's filtering, pagination, skip limits, etc., all the things that we expect our database to do. Any questions, comments? Nope. Okay. Very good. So one of the things we'll walk through today is the sorry, just moving a little bit of the files or a little bit of the windows around, is the OSO's configuration language. So this is called Polar. This is a domain specific language that we've created to define our policy. So it's the way that I like to think of it is sorry about that. The way that I like to think of it is kind of like a rules evaluation language.
Yes.
Okay. It's a Polar is a domain specific language that is a kind of like a rules evaluation language. I think of it like the way SQL is used to define a schema, Polar is used to define a policy, and that policy defines a set of rules that determine how we define if we have access or not to a system. So here is an example of a resource. Resources are ways that we kind of group our objects that we're looking to protect in Polar. And that allows us to do things that allows us to create groupings such as roles, permissions, as well as relationships. So here you can kind of see we have some of our relationship-based access control. So if a owner becomes an admin, if they belong to the organization, and then here we also have our attributes as well. If the resource is public, the user has read, as well as they're a member of the organization. Any questions, comments? Great. So the final thing is I'm going to show you a set of so we have a set of APIs that we use to determine whether a user has a given permission. We have the idea of authorize. Is a user permitted to execute an action on a given resource? We also have the authorize local, which will ask the same question, but that will return the filter that we apply to the database to allow our database to determine if the user is authorized to do so. And we have the same for list and list local. And then finally, we have a couple more APIs around getting using queries, where this is really a very powerful feature that allows us to chain together different filters, and then finally execute the query at the end. And that execution can either be against OSO or a local database. And we also have APIs that are focused around getting all the actions that a user associated with, et cetera. And we'll show some of those within the demonstration. Any questions, comments? Okay. So now we're going to just jump into the demonstration. So here we're going to, let me stop sharing this. So here we're going to go into the application that we've created. So this is a very simple application that's meant to represent users and documents, very similar to what we talked about within the presentation. So here I have a set of users that are going to be associated with organizations. I have one organization right now called _root, and you can think of this organization as the super admin organization. This would be the organization that your admins might use to diagnose and troubleshoot the application. And today we're going to walk through creating a organization. That organization will create an admin and a member, and we'll create a couple of documents just to kind of show the workflow that occurs when we're using OSO and local authorization. So one of the things here you'll see is that today we've removed the, oh, that's weird. Sorry, something just came in. So today we removed the idea of authentication. So once I click on a user, I assume that user's role. And so here I'm logging in as root. And one of the things you'll notice is that on the right-hand side, here we're showing the API request that was made. So it's a RESTful endpoint that's returning and the API response is returning all of the information about that user. So here is all of the data that is found in the database, as well as the permissions. And then here is all of the data that's derived from the database. And the OSO filter, this is the filter that we built up when we ask to get the user as well as the permissions from the database when I asked, when I sent the OSO authorized local. And I'll show you a little bit about what that API looks like in the code in a moment. And then this is the full query that gets executed when I append the filter, the OSO filter, to my database query. And we'll walk through that. So now I'm logged in as this user. So here I can kind of see the permissions that the user has. And you'll notice here is some of the here's the API calls that were executed again. And this tells me that this user here is a global admin, is also an org admin, and here are all the actions that the user can perform on our application. They can read an organization, create a user, create a document, create an organization, and delete an organization. So if we go home, the first thing that we want to do is come into the admin console. And here what we're going to do is create a demonstration, is to create a demo org. So we're going to add the org. And here you'll see that I'm executing this query, and the OSO filter said that I was allowed to create that demonstration org, and the user and the organization is now created. So one of the things you'll notice is that I put a timer in between each one of the actions so that we can kind of see the query panel refresh. So now we're going to create a admin for that demo organization that we created. And we're going to give that user admin. And again, here you can kind of see the query that's executed to show that they have permission. And then we go ahead and create the user. And we're going to then log in as that demo admin. And now you'll notice one of the things that we're able to do is this user does not have administrative privileges on the application because this user is not a super user. So this user cannot create other organizations, but they do have the ability to create users. So we're going to create a demo user that has the member permission. And here we can see the OSO filter that was used as well as the query that was executed. And now we have our users here. So now I want to go back and let's create a document. So we'll come over to the documents. We'll see that there's no documents created. So let's create a document and call it demo admin document, something along those lines, and submit. So now I've created the document for the demo admin. And here you can see that all the permissions that the user has for the document. They can read the document, edit it, set as public, delete, manage the sharing, and assign ownership. So today we can do this. We can set the document as public. We can change the user and who has access as well. So the next thing I want to kind of talk through is what the code looks like within the application. And we're going to take a look at kind of how we manage the users. So if we come back to here. So if you remember, we were over here, we come back to the user's home. We went to the admin console and we added a user. So let's come into first, take a look at the policy that we supported. Let me hide the database view, make this a little bit bigger. So you remember we first logged in as the root admin, and you'll notice that the root admin is part of our global policy scope. This gave the admin user the permission to create and delete the org. And this is how we were able to bootstrap our application and create the demonstration organizations within our application. We saw a little bit of the policy folder in the demonstrations. Here is some of the resources. We have organizations where we have admins and members. We have users. These users can be managed as well by admin members of the organization. And then we have our document resource, which we saw prior in the demonstration as well. So all of these resources are stored globally in OSO. And now when we go to ask a question, for example, when we attempt the create user, when we do the create user function here, let's make this a little bit bigger. This create user function is taking a requester who is requesting to create the user. What's the user's role? The user's name, role, and organization that we're looking to create. And we're executing this authorized user call. So this authorized user call here, we can find in our OSO library. And we come into authorize user, and what we're taking is the OSO API client, a database client, the name of the user, the permission, and we're asking if the user is allowed is the user going to be allowed to execute the permission on the given resource? This auth query is actually the OSO client is going to build the query and return a SQL query that I can then run against the database to ensure that the user has permission to return a database, to execute the permissions, sorry. And this return here is really, this is a richer return that allows for a storing on the query panel, but this query result here is going to be a Boolean value of yes or no that we then use in our authorization. Is the user allowed to create, is the requester allowed to create the user? If yes, we then create the user. And so this is essentially how the core of the system works. And then one of the things that we have here is I wanted to demonstrate, here's how we insert facts into OSO. And why would we want to insert facts into OSO if we're using local authorization? Typically, some of the things we might want to do is, hey, if we want to have other services run in isolation from the organization service, then the document service no longer needs to ask the organization service for the user information. It can now ask OSO directly and then apply its own policy to its local data as well. So this is a way of using a mix of local authorization as well as centralized authorization. So I know I walked through a lot today. So the one thing I want to first, is there any questions or comments, anything that you would like to review? This is a generic question, but how do we compare it to open policy agent? All right, well, it's been very quiet, but is there anything that, oh, hey, Justin, you have a question?
Hey, Shawn, good to see you again. Thanks for walking through this. This has been awesome. Big fan. I'm curious, can you talk a little bit more about, I'm still trying to understand how you frame the trade-offs for the different methodologies for local authorization that you provide. From what I was able to surmise, it would seem like local auth is really beneficial as a query filtering solution, whether that be for producing lists or like answering questions for those hybrid facts where you actually wouldn't already have the data up front. I wonder, like, when there's two equally good options, for example, why would I choose local auth versus, say, just query that like map from Mongo directly and then pass it as a context fact? It seems like they're kind of two sides of the same coin, and really the only value add is in like the syntactical differences. So I've yet to fully realize the value of local auth.
Yep, that's a good question. So typically, the way that I think about why we would want to use local authorization in that initial phase of, hey, I want to authorize the user. If I can echo back the question, is really, well, if I already have that ability to do that within the database, why would I ask OSO to kind of return that filter back to give me the allow or deny? Is that kind of what you're thinking?
Almost. Imagine a world where now we've fully bought into the idea of a centralized policy.
Yep.
And the question then just becomes, where does the data live, right? Is it local? Is it in the cloud? Now, in the world where it makes sense for that data to exist locally, right? That's like the steady final state. It makes sense to exist locally. I'm trying to more deeply understand the trade-off between, should I use local auth here, or should I use context facts? And it would seem like the only real benefit of local auth is, if you're going to have to make a query anyways, you might as well be able to condense your code so that there's less to maintain and think about But outside of that kind of syntactical nuance, I have yet to really fully realize the value for local auth outside of data filtering.
So the first thing is, the way that I typically think of context facts is that is data that I typically cannot derive either through the policy itself or the facts that I have locally within the data that OSO is authorized to access, right? So for example, is this user coming from what region is this user coming from? That's going to typically be from our authorization service or some type of session service that maps where the user is coming from. And I typically view that as a kind of a great thing to use as a context fact. Now, when we talk about where the data lives, one of the things that becomes powerful for me for local authorization is that typically when you look at systems where we have to have the authorization service make the decision on if they are allowed to or not to access that data, we have to upload the authorization data into that service, right? So if we have to store that data in the authorization service for it to even make those simple decisions, then what we end up having to start to think about within our microservices architecture is the synchronization, how we reconcile data when things are failing, how we do two-phase commits, all that fun stuff that we can remove by using the idea of local authorization for that one aspect. So like for the example with the a user demo, I can ask the policy to do the authorization of the user and then insert the data. I could probably use a context fact potentially, but the context fact for me that's kind of like an anti-pattern, if that makes sense. Because essentially I'm providing it rather than saying, here's where the data lives in a database. I'm getting the data from the database, sending it as a context fact to help answer that question. Whereas the other way, I'm saying, this is where the data lives, go get the answer. So I think you can do it either which way. And I know that we've kind of shown that you can do it either which way in some of the examples that we worked with, Justin. But I see kind of using a context fact as an anti-pattern. Sorry for the long answer. That was a great
question. No, that's totally fine. This feels philosophical, and so I'm hoping to go a level deeper. The framing that I have is to answer an authorization question, there's two sides of the coin. There's the policy itself. There's all the business logic for defining the authorization rules. And then there's the data needed to answer authorization questions against said policy, right? And that policy can live in either place, but in the idea of a centralized service, it makes sense for that policy to live there, which also has a beautiful way to handle that through their DSL. Now, in terms of like where the data lives, I agree that in a perfect world, all data that's exclusively used for authorization should exist in the cloud. If I don't need it for any sort of feature behavior, it should exist in the cloud, right? There's two types of data. There's authorization data, and then there's application data. And I think of authorization data as data needed to answer authorization decisions. And I think of application data as data needed to support the functionality of my application. Now, where these two things are mutually exclusive, it's very clear authorization data should exist in the centralized authorization data store, because then the answers are much quicker, centralized, you're decoupling, you're not thinking about having to synchronize data between two places, et cetera. And application data should always exist in your local store, right? Now, there is a world where there's a Venn diagram between these two, where sometimes authorization data is needed in the application, right? Imagine you have a is enterprise flag and you need to surface that in the UI. And there's a world where some application data is needed for authorization, same thing. So for that hybrid data, it still, in my opinion, makes sense to own that data locally and not centralize it, because then you have to start thinking about data existing in two places, et cetera. So that's the framing. So now we have this hybrid data that makes sense to exist locally.
Yep.
Then the question becomes, how do I instrument that to answer policy decisions, right? And there are two mechanisms that OSA provides that essentially solve a very similar problem, right? One is local authorization, where the policy needs some additional data to complete that answer in the form of querying against your database. And the other is context facts, where the data is actually supplied to the authorization server at runtime and it's able to provide the answer back. So those are two ways to solve the exact same thing. And I'm trying to really tease out and intimately understand where's that line of separation between which solution that I use for the different use cases. And it would seem like context facts, for the most part, answer all the questions in a more broad way that's less opinionated about, oh, you got to use this database and model your query this way. Just pull the data however you want and then supply this to the authorization engine. Does that make sense?
It makes sense. And so I see what you're saying. And so one of the things that becomes interesting there is that when you're sending context facts, right? And the reason why I wanted to pull up the YAML file that kind of shows the different ways that the facts can get organized is that essentially using the local authorization, we can actually create pretty complex queries that meet different requirements. So for example, here, you know, any fact that meets this has role fact structure, this query will get built, as well as the is public and the has relation. So we're going to build a more complex query that can be pushed down to your data structures. So when you're using the context facts, though, I don't know if you can cleanly represent the data structures from your database in that context fact form to answer the question. Like, it would be something I'd have to test out. I like the approach of the local authorization, because essentially as the policy is getting evaluated at each step, we say, oh, a fact is needed that matches this requirement. So this is the query that we would push down. This would be part of the query that we push down to build a really complex filter that can be applied to your database that would then allow for, you know, the pagination that you expect and things like that. And it makes it a lot easier, because now you're not managing, because from the other side of it, if we thought about it, is I would have to manage how I send the context fact up. Whereas here, I'm just asking the question and I'm managing my data binding here. That's kind of the way I'm thinking about it. Does that make sense?
To repeat it back, it seems like, to repeat it back in a slightly different way, it seems like the thing that local auth can do that context facts cannot is define complex rules, which may include wildcards, for example, right? Whereas with context facts, it's all, every parameter is statically defined. There's one answer per fact, right? And you can't have more complicated rules defined. To me, that seems like the clear differentiator. Like here, you're using underscore, whereas if you weren't using underscore, it's kind of two ways to solve the same problem.
Yeah, the context facts, I think, is for me, and that's kind of why I really like the idea of the context facts, to help just build up a smaller set of data for which I either can't derive from my data sources or I can't derive from my policy, right? And like, that's region specific data, maybe time specific data, or anything that the rest of the infrastructure knows about that I can then send to my policy to allow it to do that more complex evaluation, be it if it's centralized or local, and then make that, and then give me the decision back. Does that make sense?
It does. The other really compelling use case for context facts is incremental adoption, where, okay, like we use MongoDB for our source of truth for authoritative decisions today. And ultimately, like a lot of that data will exist in the cloud in the form of facts. But from day one, we could continue to use our existing data store, but also model the policies in whatever that final shape should look like. Yeah. And then so like everything that would ultimately exist as facts in the cloud gets passed as context facts. And then later we just rip out the context facts once that synchronization completes and we deprecate our database. So by indexing on this like path of iterative adoption, we're kind of leaning into this design paradigm of using context facts, which is a very different approach than local authorization. But with local authorization, there isn't as clear of a schema migration strategy over time that wouldn't require doing some non-trivial code refactors to get the code in the right shape to match that pattern. Does that make sense?
I see what you. I think I see what you're saying. I would like to. I think that's something I would like to, like, if you and I and the team could catch up later, I'd like to really dig into that, because I'd like to understand the challenges that we're facing with the reconciliation as compared to the context facts. I think it's an interesting approach, and I'd like to kind of dig more into that. That's pretty cool.
Also, makes sense. Yeah, your point about not having to write complex queries and doing data filtering and using wildcards to define more complex rules really makes sense. And that's like a good framing for me to understand when I would use local auth versus context facts. Thank you. I'll stop blabbing now.
No, this is a great conversation. Thank you for the questions. It it gives us a lot to think about. Hey, Ashwin.
Yo, I'm just gonna chime in here as well. I don't have the wallpaper, but I work for OSO. Yeah, I think the other thing to bear in mind with like local authorization versus like the context fact approach is that it kind of depends on how much sort of dependent data the resource that you're trying to authorize against is dependent upon for like other resources. So like relationships to other data that aren't necessarily on the piece of data that you're actually querying for. So for example, like you might be querying for a file which belongs to a folder, which belongs to a project, which belongs to an organization. And if you were to take the context fact approach, you would need to query for like the entire hierarchy, right? So I think with all of these things, like it really is a lot of like balancing like trade-offs. And so like we've really invested a lot of time into like creating a flexible system so that you're able to kind of pick the approach that makes the most sense for you. If you are in a situation where like you don't actually have any list sort of queries to make on like a file resource because you don't have that view in your UI, for example, and all of the authorization data is like purely on like the file and like some global user identity stuff, then I completely like agree with the rationale that like context facts will be completely like sufficient in that case. But when you get into that situation where the data kind of lives elsewhere outside of the resources that you're querying for, it can get more complicated than that. And additionally, like you kind of spoke about yourself, Justin, typically we see like you do have these like list sort of UI views like all of the time for a lot of these resources. So people would just generally kind of prefer to like not have multiple kind of ways to to achieve the same thing if they're trying to handle authorization for their particular resources. But yeah, that first part is like the main point I was trying to drive at.
That resonates big time.
Cool. Great question, by the way. And I appreciate your framing.
Yeah, very good question. Yeah, definitely. Also, you know, we have for everyone here, we have a Slack community. Hazal has put that in the chat, as well as if you have any questions or anything you want to do, more than happy to reach out. You know, you can reach out, and we're more than happy to get you the answers and run through demonstrations. I'll also be we'll be making the code public. There is a bit of cleanup I have to do. I don't know if you noticed, there were some to-do marks and stuff like that, but that just comes with me being a terrible programmer. So I'll have those up by the end of the week. And if you have any questions, please don't hesitate to reach out.
You're not, there's no such thing as a great programmer. There's just less terrible programmers. So I'm right there with you.
I fall into more terrible. So, well, thank you very much for everyone for attending, and please do reach out if you have any questions. It's be more than happy to help. All right.
Bye, everyone.
Take care.